So we're on page 473 of your Math 20 Absolute Value workbook, and today we're looking at absolute value transformations. And I think at this point you guys should be pretty solid with this because we looked at this when we first introduced absolute value functions. So just a reminder then, so recalling the definition of an absolute value, we can divide this into, or rewrite this as a piecewise function. So the absolute value of x, it looks like, so the function x, absolute value of x looks like y equals x anytime in our subdomain when x is greater than or equal to 0, and it looks like the graph of y equals negative x when we're in the subdomain of x less than 0. So an absolute value transformation basically takes y equals f of x into y equals absolute value of f of x. That certainly makes sense. I think the toughest thing with this particular section, if anything, is just getting our heads around some of the notation or the terminology of f of x, because you guys are so much more used to just y equals or our equation notation. So we've got a function f of x with the equation y equals x minus 1. So write the equation for y equals the absolute value of f of x. So we're just simply looking at y is equal to the absolute value of x minus 1. And so then let's complete the table of values. So y equals f of x is essentially, remember, is just y equals x minus 1. So negative 4 minus 1 is, of course, negative 5. And we'll just fill that in. Negative 3, negative 2, negative 1. And 1 minus 1 is, of course, 0, 1, 2, 3. And then y equals the absolute value, so that is y is equal to the absolute value of x minus 1. So we've already got our x minus 1 values here, so if we simply take the absolute value of negative 5, that is of course 5, 4, 3, 2, 1, 0, absolute value of 1 is just 1, 2, and 3. And so now we're asked to sketch both graphs. So if I sketch the graph of y equals x minus 1, then again we know our x-intercept is negative 1 and slope is positive 1. So rise over run. So let's just use my line drawing tool, and there we go. So this is the graph of y is equal to f of x, also known as y is equal to x minus 1. When we graph the other one, though, what we'll see of the absolute value is that, whoops, we end up with all of these points right here. Oops. And there's going to be a bit of an overlap here as well, and I'm not sure where this guy came from. Okay, so what do we notice then is this is y is equal to the absolute value of f of x. So when we see that, then when f of x is greater than or equal to 0, so looking at greater than or equal to 0, then the graphs are what? So anytime I'm looking at quadrants 1 and 2, when f of x is specifically this blue graph, we can see that they are actually identical. Whereas when f of x is less than 0, then that is this blue part below in quadrant 3. What we see is that the y equals the absolute value is actually a reflection of that graph. Okay. So same thing right here. So we can see the graph currently of our quadratic, y equals x squared minus 4. So the equation for y equals the absolute values, of course, y equals the absolute value of x squared minus 4. So if we use our graphing calculator, or if we just think it through, what's happening is that because we're taking the absolute value of all of these values below, then we end up with a reflection of that. So this green graph then is the graph of y is equal to the absolute value of f of x. Okay, and so do the observations from 1D also apply in this example? Absolutely. So anything that is already above the x-axis in the original graph stays and is identical. Anything that is below the x-axis then reflects into above the x-axis. Okay, so you can read through those characteristics, and let's take a look then. So if the graph of f of x is shown, then graphing y equals the absolute value of f of x. So the graph of the absolute value is essentially anything that is below the x-axis is going to reflect above. Anything that's already above is going to stay the same. So this piece right here, I'm just going to trace over it because it's important to show that this is also part of the absolute value graph as well. So that stays the same. Anything that's below is reflecting up, so it's probably just key to look at those kind of points where things change. So the, right there, and then it goes across. So this green graph then is y is equal to the absolute value of f of x. So anything below comes above. So since everything for part B is below, the whole thing is going to reflect. So I'm looking for some key points right here, and so this should look like it's quadratic now opening up. So this is y equals the absolute value of f of x. Okay, so let's take a look then. So is the domain going to change at all? So will the domain change? Nope, it is exactly the same. The range, well, the range is going to be everything that is greater than or equal to 0, but will it always be greater than or equal to 0? No, because if we take a look at B, in fact, we're actually greater than or equal to positive 1. So we can say that the range of y is equal to the absolute value of f of x then includes all values of f of x when f of x is greater than 0. I'll just use this symbol here, greater than 0, and all values of negative f of x. So basically, if it was negative 1, for example, right here, then becomes negative of that, which is positive 1, when f of x is less than 0. So essentially everything that's all this statement says is that anything that was already greater than or equal to 0 stays the same. Anything that was less than 0 now becomes the opposite of that. So -1 times those values. So x-intercepts, any x-intercepts stay exactly the same in both functions. The y-intercept, again, if it was positive, then the y-intercept stays the same. If the y-intercept was negative, then we're taking the opposite of that again. So if the y-intercept of f of x is positive, then the same. And then if the y-intercept of f of x is negative, then the y-intercept of the absolute value of f of x is the opposite. Okay, excellent. So that's basically it. Let me know if you have any questions. Thank you.